Hello, in this video we are discussing very important part of electrical circuit analysis, and that is the transient analysis. Today we are discussing basics related to the transient analysis and part 1. So in this part 1 we'll see the definition of transient analysis. When we change the applied source to the electrical network which contains energy storing element such as inductor, capacitor, the response current or voltage changes from one state to another, and the time required to change from initial steady state to final steady state is nothing but transient response. Let's understand it in detail. Now this is the RC circuit. Here switch is open, means this 10 volt supply is not connected to the RC circuit. Capacitor is energy storing element. Now we'll close this switch. It indicates that this 10 volt supply is applied to the RC circuit. Now for the energy storing element like capacitor or inductor, the voltage across capacitor cannot change instantaneously. It changes gradually. It will take some time to reach to the final steady state. Means what? Here at t is equal to 0, I am applying this 10 volt. Before that, voltage across the capacitor is 0. No energy is stored into the capacitor. So what happens at t is equal to 0? When I will close this switch, the voltage across capacitor will start increasing from 0 volt to the 10 volt. So it will take some time to reach to the 10 volt. So this is initial steady state and this is final steady state, because after this state, after this 10 volt, voltage across capacitor remains 10 volt. It will not increase above 10 volt. So this is final steady state and this is initial steady state. Before applying 10 volt, what is the state of the capacitor is called the initial, and this is the final. So to reach to the initial, from initial steady state to the final steady state is called a transient response. Now we'll consider another case. This is the first case where zero initial conditions, means before applying this 10 volt, the voltage across capacitor is 0. That's why zero initial conditions. Now second case is with initial conditions, means before applying this 10 volt, some charge is there into the capacitor. Already capacitor is charged up to suppose 2 volt, and then we'll close this switch. So already capacitor is charged up to the 2 volt. After closing the switch, it will start charge from 2 volt. That means your graph will be like this. At t is equal to 0, I am closing the switch, but already this 2 volt charge is developed across the capacitor. So from t is equal to 0, the voltage across capacitor will start increasing from 2 volt. Here you can check, it will start increasing from 0 volt, here from 2 volt. That means with 0 initial conditions, if capacitor is not charged before applying this 10 volt, before closing the switch, capacitor will start from voltage increasing from 0, and here it will start increasing from the initial conditions, whatever the charge developed across the capacitor before switching. Similarly, for inductor, the current through the inductor cannot change instantaneously. It will take some time to reach to the final steady state. So like this, in transient analysis, we need to consider the initial conditions. That means before applying or before changing the source, what is the state of the inductor and capacitor we need to consider. So here initial state is already 2 volt charge is there into the capacitor. Here 0 volt. So this is the initial state and this is the final state. This is the initial state and this is the final state. So both the cases we need to consider whenever we are solving transient analysis type of example. This is for RC. Like this we can correlate for the RL circuit. In case of inductor, you need to consider current through the inductor cannot change instantaneously. It will take some time to increase or reach to the final steady state. So before switching or initial conditions we are representing by time instant 0 minus. because at t is equal to 0, we are closing the switch. So before that means 0 minus and immediately after that 0 plus. So here V of 0 minus is 0, V of 0 minus is 2 volt. Same you can correlate for inductor. Inductor, current through the inductor cannot change instantaneously. It will increase gradually. It will change from one state to another state gradually. Now, what type of example comes in case of transient analysis? First, always remember what type of examples are there. So it will be easy to decide what we want to find. Find initial conditions V of 0 plus, I of 0 plus, di by dt of I of 0 plus, d square I by dt square at t is equal to 0 plus. Instead of I, it can be dv by dt or d square v by dt square at t is equal to 0 plus. Why we are calling it as a initial conditions? Because all these are at a t is equal to 0 plus, means immediately after switching. That's why we call it as an initial condition. Second type of example, determine V of t, I of t for t greater than 0. Now these are not initial conditions. We want to find for any instant of time which is greater than t. And third type is same. Determine V of t, I of t for t greater than 0. Change is using Laplace transform. Means this is in a time domain and this is in a Laplace or frequency domain. Using Laplace transform means frequency domain. So we are converting our network into the frequency domain and then we are solving. But purpose is same, to find V of t and I of t for t greater than 0. Now some basics we need to remember. This is the switch. Now when the arrow is like this, it indicates that at t is equal to 0, we are closing the switch. And when your arrow is like this, it indicates that at t is equal to 0, we are opening the switch. So always for all the transient analysis type of example, you need to draw three type of equivalent circuit. At t is equal to 0, t is equal to 0 minus and t is equal to 0 plus. So these three equivalent circuit you need to draw and then start your analysis. Thank you.